Have you ever wondered how they calculate a home run's distance before the ball even lands? Or how a rocket's path is plotted with just insane accuracy? Well, that's not magic. It's physics. Specifically, it's kinematics, the language of motion. So let's dive in and figure out how to describe the journey of pretty much anything that moves.
All right, here's our game plan. We're going to build this whole thing from the ground up. We'll start with the super simple question: where is something? Then we'll bring time into the picture to talk about speed and its cousin, velocity. After that, we'll get into how motion changes. And finally, we'll unlock the 4 power equations that let you predict motion like a pro, even with something as huge as gravity.
So, first things first, where are we going? I mean, before we can even think about how fast something is moving, we have to agree on where it is and where it's been. This is the absolute bedrock of kinematics, so let's nail this down. Okay, let's start with a word we all know, distance. This is basically your car's odometer or the step counter on your watch. It just adds up every single step, every twist, every turn of your entire journey. That's it. In physics, we call this a scalar. It's just a number, no direction, nothing fancy. But, physicists like to be a little more precise. And that's where displacement comes in. See, displacement couldn't care less about the scenic route you took. It only cares about the shortest, straightest line from your starting point to your finishing point. And because that line points somewhere, it has a direction. We call that a vector. Now, to really see the difference, just picture yourself running one lap around a 400-meter track. Your distance is, pretty obviously, 400 meters. Your legs will definitely feel those 400 meters. But what's your displacement? Well, you ended up in the exact same spot you started, right? So your displacement is 0. A big fat 0. That one idea is absolutely crucial for everything we're about to cover.
Okay, part 2. Speed versus velocity. We figured out how to talk about a change in location. But a journey isn't just about where you go. It's also about how long it takes you to get there. So it's about time we added, well, time.
Average speed is the one you already use every day without even thinking about it. You just take the total distance you traveled, our full 400-meter lap, for instance, and you divide it by how long it took. Super simple. It gives you one number that tells you, on average, how fast you were going.
Average velocity, on the other hand, uses displacement. So think back to our track runner. After that one full lap, their displacement was 0, remember? So if we divide 0 by the time it took, their average velocity for the whole lap is also 0. Sounds totally weird, I know, but it's true, because from a physics point of view, they didn't actually end up anywhere new.
So here's the bottom line. Speed is a scalar. It's just a number on your speedometer. It tells you how fast. Velocity, though, is a vector. It tells you how